this video will focus on the learning target, I can use collision theory to explain how different factors affect the rate of the reaction. So step one, what is collision theory? Collision theory is the idea that for a reaction to occur, you actually need to have your reactants come in contact with one another, actually collide, to be able to make product. So you can't make product if the atoms aren't close enough together to make a new bond. So in order for a reaction to happen, essentially the reactants have to collide, and they have to collide with enough energy to break and make new bonds, and they have to be able to collide with proper orientation for the products to be able to be formed. Okay, so when you think about our reaction pathway and the fact that we have that activation energy, what the activation energy is actually going towards is making what's called an activated complex. So if you look at the diagram kind of all the way over with the red and the black, that shows an idea of proper orientation. So if in the end it's the green that needs to bond in a specific location, it has to be oriented in such a way that we break the bonds that are being broken and are able to make new bonds by where the atoms are. So because it's the hydrogen that needs to combine, in the case of that diagram with the green and black, you need to orient the molecule that when they hit, the hydrogen is oriented towards the other reactant so that new bonds can actually be formed. In the other two pictures, it actually shows you what the activated complex looks like. So if my reactants are oriented properly, when they come together with a lot of energy, they're oriented in such a way that the bonds that are currently there break and new bonds can form. And that's the activated complex. Okay? So collision theory is around the idea that for a reaction to occur, I need my reactions to hit, and they need to hit with enough energy that the bonds can be broken and new bonds can form. But they also have to hit at proper orientation. So there are times when I can have collisions that have enough energy, but because they're not positioned appropriately in space, no reaction happens. Now again, in relation to this reaction mechanism or this kind of energy pathway for a reaction, that activation energy has to do with that activated complex. So I need to put enough energy in to break the bonds, and that activated complex has to do with that transition molecule that's being made. So right there at the peak is where I have these middle compounds, these ones where bonds are broken, but no new bonds are formed, but I'm kind of making this transition state, or this activated complex that's ready to become product. Collision theory then can explain what affects the rate of the reaction. Okay, so in order for a reaction to happen, reactants have to hit with proper orientation and enough energy to make the reaction happen. And so if I can make that happen faster, I can make my reaction happen faster. So here are the factors that affect how fast a reaction can happen. Okay, if I have smaller particle size or larger surface area, if I have a higher temperature, if I have a higher concentration, or if I have a catalyst present, all of those things can affect the rate at which my reaction happens. Okay? If you break down any of these things and try to explain why they affect the rate, all of these things will be able to explain by saying they increase collisions that happen with proper orientation or with enough energy. Okay? So if I take the particle size and I decrease the particle size or increase surface areas, I'm essentially increasing the possibility of having collisions. Okay, so just by increasing potential surface area, I'm increasing how many collisions that can happen, thus making the rate go faster. If I increase temp, similar, I'm increasing that energy input. So in terms of proper orientation and enough energy, I'm putting in more energy, so that should speed up the rate. For concentration or for pressure for gases, I'm increasing collisions by just having more available, so they're just going to hit each other more often, so the rate will happen more quickly. And then for catalysts, we've talked about how a catalyst decreases the activation energy. By decreasing activation energy, my rate will go faster, just because you have less of a barrier. Another thing that catalysts do, and I'll show this to you in class, is catalysts actually can serve to enhance how often the proper orientation happens. So sometimes the catalyst will actually come and hold your reactant in a specific way, meaning if reactants come and hit one another, they can only hit at one direction, thus increasing the likelihood of a proper orientation. So catalyst not only decreases the amount of energy needed, but it also sometimes facilitates that proper orientation component. That's it for this video. Go ahead and do the quiz and have a nice night.